Okay, good morning everyone. Welcome to visiting lecture event with the theme of blockchain, which will be presented by Dr. Burhan Islam. The agenda for today in of the Department of Informatics, Ponegoro University, session.
Eh, saya kira untuk materi blockchain ini sudah saat ini cukup banyak ya dibahas di beberapa hal gitu ya. Di adik-adik mahasiswa, terutama mahasiswa angkatan 2022 yang mengambil mata kuliah sistem informasi dan angkatan 21 ya, yang mengambil mata kuliah audit sistem informasi akan bisa belajar banyak dengan narasumber ya terkait dengan terapan di blockchain karena ini sudah luar biasa sekali perkembangan di blockchain terutama beberapa terapan di bidang pemerintahan misalnya ya di kesehatan maupun di keuangan sehingga nanti visiting lecture kali ini akan banyak memberikan pencerahan kepada adik-adik mahasiswa maupun teman-teman dosen yang bisa bergabung pada hari ini. Sekali lagi saya ucapkan terima kasih kepada Dr. Burhan Islamkan yang telah bersedia hadir dan memberikan materi di kegiatan visiting lecture pagi ini. Itu saja yang bisa kami sampaikan. Semoga visiting lecture kali ini banyak memberikan manfaat kepada kita semua. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Mohon maaf ini Pak Aris, mungkin MC-nya baru nge-lag ini. Okay. Okay. Mungkin I will continue the visiting lecture. So before we start the visiting lecture, we participant open the camera and we will be going to take a picture together. Sorry, because I have a trouble with the MS Teams, so we will going to start for taking picture. Please then open your camera and I will take picture for you. Okay. Okay, second screen. Okay, before I thank you for the time, and I think I will call Dr. Burhan.
Assalamualaikum warahmatullah. Good evening, Professor.
Waalaikumsalam warahmatullahi wabarakatuh. So right now, I going to also call the Ibu Dena Kamalia as a moderator.
Yes, good, Virginia.
Okay. So it's time for the visiting lecture topic. So please, this is your time.
Thank you. So please confirm if my screen is visible to all the participants.
Uh,
Demo
I think we see your picture, but sorry, we cannot see your share screen. Maybe right now, Ibu Dena Camelia will be the moderator for your session, Dr. Burhan.
Thank you, Prof.
Please, Ibu Dena.
Okay, thank you so much, Ibu Dinar, for the great introduction. The Honorable Dr. Aris Sugiharto, SSEMCom, as the Head of Informatics Department, Faculty of Science Mathematics, University Diponegoro. The Honorable Dr. Burhan Ul Islam Khan, lecturer from the Faculty of Computer Science and Information Technology, University Malaya. And the Honorable lecturers and staff of the Informatics Department, Faculty of Science and Mathematics, University Diponegoro. And all participants and students of Informatics Department, Faculty of Science and Mathematics, Diponegoro. Good morning, everyone. I will choose. Blockchain is a ledger that facilitates the process of recording transaction and tracking assets in a business network. Blockchain technology produces a data structure with inherent qualities. It is based on principle of cryptography, decentralization, and consensus with ensured trust in transaction. In today's quiz lecture session, we will learn and discuss further development of blockchain technology in data security and data transmission, and of course, the role of human in it. Now, let's start today's session. Our lecture today is delivered by Dr. Burhan Ul Islam Khan, who will guide us through today's class. Before starting the presentation, let me briefly introduce Dr. Burhan. Dr. Burhan Ul Islam Khan is a lecturer from Department of Computer Science, Computer System and Technology, Faculty of Computer Science and Information Technology, University Malaya. For his educational background, Dr. Burhan studied computer science and engineering at Islamic University of Science and Technology for his undergraduate degree, and then got his master's degree from International Islamic University Malaysia in Computer and Information Engineering, and also got his PhD in Computer and Information Engineering in International Islamic University Malaysia. Since 2013, he has been involved in many research projects in many areas, such as network security, cloud computing, online payment system, and data transmission. He has conducted research and published over 40 articles in various international journals. Apart from conducting research, he is also active as a reviewer in several journals, such as Cluster Computing, Wireless Personal Communication, and the Journal of Supercomputing. And there must be much information we can learn from today's lecture. Before we start the course, let me read the agenda. In today's lecture, we have two agendas. The first agenda is the main lecture from Dr. Burhan, and the second agenda is the question and answer session. And we expect all the participants to participate actively in this session. And during the session, you may type your question in the chat box, or you may also deliver the question directly to Dr. Burhan in the question and answer session. And now, without further ado, let's start with the first agenda, the main lecture presented by Dr. Burhan Ul Islam Khan. Please welcome Dr. Burhan. The time is yours.
Thank you, Ms. Dina. In the name of Allah, most beneficent and merciful. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. It's a pleasure to be here with you today. We are going to dive into the topic that has garnered immense attention across various industries, that is blockchain's technology. So before we dive into blockchain technology, I would like to introduce myself briefly. I, Dr. Burhan Islam Khan from Faculty of Computer Science and IT at University Malaya. I have the privilege of working extensively in the fields of blockchains, cryptography, distributed systems, and IoT. I have published several research papers on blockchain technology with particular focus on its applications in finance, supply chain management, and data security. Today, I'll be sharing insights from both my research and the wider blockchain ecosystem, aiming to give you a comprehensive introduction to this technology. These are some of my publications. So when I first ventured into the world of blockchain technology, it was back in 2022 with my first paper titled A Comprehensive Insight into Blockchain Technology, Past Development, Present Impact, and Future Consideration. It was challenging yet a fascinating journey to research and understand the core principles of blockchains, as well as its potential across various industries. In 2022, I also worked on decentralized blockchain network for resisting side channel attacks in mobility-based IoT, focusing on blockchain's resilience to side channel attacks. Continuing this journey, I drove deeper into IoT applications with another publication in 2024, that is blockchain enhanced sensor as a service in IoT. Leveraging blockchains for efficient sensor data. Here I explored blockchain serve as a backbone for secure sensor transactions, ensuring data integrity, protecting against potential vulnerabilities in IoT ecosystem. Really recent publication of mine, where we actually try to integrate AI and blockchains for enhanced data security in IoT-driven smart city scenarios. We examined both AI and blockchains, okay, and integrated them, how they could actually be used in context of smart cities. The intersection of AI, IoT, and blockchains opened up new avenues of thought and pushed me to understand how these technologies could mutually enhance or complement each other, especially in security settings. Before we jump in here, here's a quick roadmap of what we will cover today. We'll start with the basics, defining what blockchain is, and reviewing some essential concepts. From there, we will explore how the technology works, different types of blockchains, and real-world use cases. Towards the end of the session, we will discuss some challenges and limitations of blockchains, as no technology is perfect, same is the case with blockchains. Finally, we will take a look into the future of blockchains and its potential to evolve further. This should give you a holistic understanding of this fascinating technology. What exactly is blockchain technology? At its core, the blockchain is a distributed ledger technology. Think of it as a database that isn't stored in one place, but shared across multiple computers. each referred to as node on a network. Each block in a blockchain contains a cryptographic hash of the previous block, a timestamp, and a transaction data. What makes blockchains unique is its ability to secure this data in a way that doesn't require a central authority, like a bank or a government or trusted third parties. Instead, the technology uses cryptographic algorithms, such as hashing at the basic level and maybe public key encryption at the advanced level to ensure the data remains secure and trustworthy. So this is the history of the blockchains. Blockchain's origins goes back to 1991 when researchers Stott Haber and Scott Storneto described cryptographically secure chains of blocks. This foundation work was expanded in 1992 with Merkle trees were introduced to design, make it more efficient by grouping several document certificates in one block. However, blockchain truly gained prominence in 2008 when an individual or a group referred as Satoshi Nakamoto conceptualized its use for Bitcoin. Since then, blockchain technology has evolved rapidly, growing from Bitcoin's humble beginnings to an part of various industries. The fundamentals of blockchain revolve around a few core concepts. First, it is a decentralized public ledger, meaning that no single entry controls it. The data is distributed across a network of computers, resilient against cyber attacks. Encryption is another critical aspect. Blockchains use cryptographic algorithms such as SHA-256, 512 to ensure that the data remains secure. This brings us to proof of work, referred as POW, which is one of the consensus mechanisms used to validate the transactions. Miners compete to solve several puzzles to verify transactions, and in return, they are rewarded usually with cryptocurrency like Bitcoin. Architecture of blockchains. So let's take a closer look at the architecture of the blockchain. At its core, a blockchain network consists of various components. The most fundamental unit is the node, which is essentially a user or a computer participating in blockchain. Each transaction, the smallest building block, is grouped into blocks, which are distributed across all nodes in the network. The block itself is a data structure that contains a set of transactions. These blocks are then linked together in a sequential order, forming the chain. Specific nodes called miners play a key role in verifying blocks. This process is governed by consensus mechanisms. Consensus is a set of rules that ensure all participants agree on the blockchain's current state. So now let's explore what exactly makes up a block in a blockchain. Each block is composed of several components. First, there is transaction data which stores all relevant information such as the sender, receiver, and the amount transferred. Then we have a hash, a unique cryptographic signature that identifies the block. The key feature here is that each block also contains the hash of the previous block, which links it to the preceding block. A concept that has been borrowed from the concept of data structure linked lists. This creates an unbreakable chain of blocks. Any attempt to alter a block's data would change its hash, breaking the chain and altering the network, which ensures the immutability of the blockchain. Working of blockchain. So how does blockchain actually work? When a transaction is initiated, it is first broadcasted to the entire network. The network of nodes verifies the transaction using predefined rules, ensuring its legitimacy. Once verified, the transaction is grouped with others to form a block. This block is then added to the chain through a consensus mechanism like proof of work or proof of stake. The process of adding the block to the blockchain ensures that the transaction is immutable and transparent. Every node in the network now has an updated version of the blockchain, guaranteeing trust without the need for central authority. Types of consensus algorithms. Consensus algorithms are the backbone of blockchain technology as they ensure all nodes in the network agree on the validity of transactions. The most common algorithm is the proof of work by Bitcoin, where miners solve complex cryptographic puzzles to validate transactions. Another popular method is the proof of stake used by Ethereum, where validators are chosen based on the number of coins they hold. There is also DPoS, delegated proof of stake, which allows token holders to elect delegates to validate blocks. Other algorithms include Byzantine fault tolerance and practical Byzantine fault tolerance, each with unique approach to maintain consensus. What is a POW algorithm? Proof of work is the original consensus mechanism used in blockchain, and it's crucial for ensuring security and integrity of networks like Bitcoin. In POW, miners compete to solve a complex mathematical puzzle, and the first miner to solve it gets the right to add a new block to the blockchain. This process requires significant computational power and energy, but it makes it extremely difficult for malicious actors to tamper with the blockchain. The miners are rewarded for their efforts with cryptocurrency like Bitcoins as an incentive to maintain the network operations. POW remains one of the most secure consensus mechanisms, though it comes with high energy cost and also computational costs. Working of POW. In the POW system, when a new transaction is initiated, it's grouped with other transactions to form a block. To add this block to the blockchain, miners must solve a cryptographic puzzle, which requires finding a hash value that meets certain criteria. This process involves repeatedly calculating hashes until a suitable value is found, which is computationally intensive. Once a miner successfully solves the puzzle, the block is added to the blockchain and the miner is rewarded. This process secures the network by making it difficult for anyone to alter the blockchain without controlling more than 50% of the computational power. Now moving on to types of blockchains. There are several types of blockchains, each suited to different use cases. The most well-known is the public blockchain like Bitcoin or Ethereum, which is open to anyone and operates in a fully decentralized manner. Private blockchains are more controlled and only selected participants can join and validate transactions, making them ideal for enterprise use. Consortium blockchains are hybrid, where a group of organizations jointly manage the blockchain. Finally, we have hybrid blockchains, which combine elements of both public and private blockchains, offering transparency in some areas while keeping certain operations private. Each type of the blockchain has its own strengths and is used based on specific needs of a project or an organization, or for that matter, business requirements. What makes blockchain technology so important? Blockchain is a revolutionary technology because it solves several key issues in digital systems. First, it provides enhanced security, making it much more harder for hackers to compromise data. Blockchain's decentralized nature eliminates the need for intermediaries such as banks, brokers, trusted third parties, thus reducing and speeding up transactions. The transparency inherent in blockchain also means that transactions can be traced and verified by anyone, ensuring accountability. This immutability ensures that the data is written, it cannot be changed or, for that matter, altered or deleted, which is critical for applications where data integrity is of utmost importance. This makes blockchain application domain to range from industries like finance and beyond. How does blockchain work? The fundamental goal of blockchain is to enable digital information to be recorded and distributed, but not edited. This is why blockchain is often referred to as a distributed ledger technology. Every transaction or piece of information is recorded on multiple nodes across a network, ensuring that no single entity controls the data. This decentralization makes the data tamper-resistant. Once a block is added to the chain, it is there permanently. Blockchain first gained attention with Bitcoin in 2009, but since then its applications have expanded into other areas, including decentralized finance, non-fungible tokens, and smart contracts, all of which offer new ways of conducting business and managing data. Transaction process in blockchains. The transaction process in blockchains is most transparent and secure. First, a transaction is initiated by a participant in the network and broadcasted to all the nodes. The nodes, which act as validators, assess the transaction's legitimacy. Once validated, the transaction is added to a block along with other validated transactions. The block is then added to the blockchain using consensus mechanisms such as proof of work or proof of stake. Once the block is added, the transaction becomes part of the permanent blockchain, viewable by all participants and cannot be altered anymore. This process ensures trust, transparency, and security without the need of intermediaries. Decentralization in blockchain. Decentralization is one of the most important features of blockchain. Unlike traditional systems where central authority controls the database, blockchain spreads the control across a network of participants referred as nodes. This distribution of power reduces the risk of corruption or tampering since no single entity can alter the data. It also eliminates the need for trust between participants as the system itself ensures the integrity of transactions. Decentralization fosters transparency and reduces dependency on intermediaries, which can lead to inefficiencies and security vulnerabilities. In a sense, blockchain shifts control away from centralized authorities and puts it back into the hands of the user. Why is decentralization important? Decentralization is a cornerstone of blockchain technology, as its importance cannot be overstated. Traditional systems rely on centralized authorities such as banks or governments to manage transactions and data. This creates a single point of failure where the system can be compromised by hacking, corruption, or simply the system or the procedure is inefficient. In contrast, decentralized systems distribute control across a network of participants, making it more resilient to attacks or manipulations. Decentralization also enhances transparency since all participants have access to the same information. While it may result in lower transaction speeds compared to centralized systems, the trade-off is improved security, fairness, and reduced reliance on intermediary parties. Applications of blockchains. Blockchain's versatility has led to its application across a variety of industries beyond just cryptocurrencies. In finance, blockchains enhance faster and cheaper cross-border payments by eliminating the need for intermediaries like banks. In healthcare, blockchains can securely store and share patient records, ensuring data privacy while allowing authorized parties to access the information when needed. Supply chain management systems benefit from blockchain by enabling transparent tracking of products and goods from production to delivery, reducing fraud, ensuring authenticity. Blockchain is also being explored in sectors such as real estate, insurance, and even voting systems, where trust, security, and transparency are paramount. So these are some of the use cases. So when we refer to the money transfers, the original concept behind the invention of blockchain is still a great application. Okay, so the concept started or was developed for cross-border transfer of money, okay, which still remains a prime application domain. So we saw how blockchains could actually promote financial exchange, so they could be used in lending. So many of the newcomers actually confuse the two concept, like confuse the Bitcoins with blockchains. Okay, so the Bitcoin is based on blockchain, but the two concepts are actually, or the two terms are somehow different. It's important to distinguish between Bitcoin and blockchain. Bitcoin is a digital currency, while blockchain is the underlying technology that enables it. So we can think of Bitcoin as an application, while blockchain is the infrastructure that powers it. Blockchain provides the decentralized, secure, and immutable ledger that records all Bitcoin transactions, but its applications extend far beyond cryptocurrency. Blockchains can be used for smart contracts, decentralized finance, and even non-fungible tokens. While Bitcoin is the most famous use case, blockchain's potential is much broader, offering solutions for industries ranging from healthcare to supply chain management. Here are some of the advantages of blockchain technology. Blockchain offers several significant advantages. One of the most important is that it is open and accessible to anyone, making it a truly democratic system. It also provides verifiability, as anyone with access to the blockchain can independently verify the accuracy of the data. The blockchain's immutability ensures that records on information once stored are permanent and cannot be altered. Its decentralized nature and use of cryptographic techniques make it highly secure, protecting data from tampering and unauthorized access. Moreover, blockchains increases efficiency by removing third-party intermediaries from transactions, reducing the potential for errors, speeding up the process. Finally, it helps reduce costs by eliminating the need of middlemen, making it an attractive solution for businesses. Now let's move to the disadvantages of the blockchain technology. While blockchain has many advantages, it also has its drawbacks. One of the major challenges is scalability. The fixed size of the blocks means only a limited number of transactions can be processed at a time, leading to slower transaction speeds as the network grows. Additionally, blockchain is energy intensive, particularly in systems like Bitcoin's proof of work, which require significant computational power. Another issue is the time it takes to add new blocks to the chain, as miners must compute a suitable hash value, which can be a slow process. Legal and regulatory challenges also exist, as blockchain technologies such as cryptocurrencies are banned in some countries. Lastly, because blockchain data is stored on all network nodes, increasing transaction volume would require significantly more storage, potentially leading to issues in future. In conclusion, blockchain technology has transformed the way we think about data security, transparency, and trust. While Bitcoin was the first successful implementation of blockchain, the technology has since found application in numerous industries, from finance to healthcare and supply chain management. The decentralized nature of blockchain eliminates the need for centralized authorities, empowering users and fostering greater transparency. Although challenges such as scalability and energy consumption still remain at the forefront of integrating blockchains, but there is an extensive research going on all over the globe to find better solutions. Okay, as we look to the future, it is clear that blockchains will continue to play a pivotal role in reshaping industries and creating new opportunities for innovation. Whether you are a developer, a business leader, or simply interested in some emerging technologies, understanding blockchains will be a key to navigating the digital future. This slide provides references for the sources and the material used throughout this presentation. Blockchain technology is a rapidly evolving field, and staying up to date with latest research and developments is crucial for anyone interested in this space. These resources can provide you with further reading and deeper insights into the concepts we covered today. I encourage the students to explore them as you continue learning about blockchains and its applications. Thank you.
All right. Thank you so much for Dr. Burhan Islamhan. It was an insightful presentation. Okay, now we are going to the Q&A session. We will have two Q&A session with 3 questions in each session. Okay, for the participant who want to ask Dr. Burhan, you can raise hand and unmute your microphone, or you can write on the chat box. Okay, for the participant who want to ask, you can just raise hand or write your question in the chat box. Okay, before any participants here. Oh, okay. There is one question, one participant who raised. You can unmute and ask the question, please. For Abian Setianeva, please.
Okay. Is my voice
Yes,
and
clear.
okay. Ini pakai bahasa Indonesia atau in English?
In English, please.
Okay. Thank you for letting me ask a question. So my name is Abian Staneva from Informatics Department as a student. So my question is, as Mr. Burhan said before, that when we mining on a blockchain, we use such a thing as a proof of work. And as I read, proof of work requires significant computational power and consumes a lot of energy. And so I think it's so unfriendly to the environment. And as of now, is there any alternative solution to prevent or reduce it? Thank you.
Okay, so it's a good question. Okay, so proof of work is one of the consensus algorithms that is used by uh, more specifically by Bitcoin technology. Yes, and the operations are resource centric in terms of storage and computations, but this is how it is at right now. Researchers all over the globe are trying to develop less resource centric approaches for consensus process in blockchains. Okay, so that is one of the reasons, that is one of the impediments in the global integration of blockchains as of now. But in the future, our computational power with our computational power of the devices will also be increased, and some active research would actually also bring the resource intensiveness of the current consensus algorithms. So in the future, we will have a trade-off. And about the environment, okay, so I don't think we can link it actually right now to the environmental settings like climate change, global warming. Yes, in the future, okay, if there are some concerns like that, okay, maybe environmentalists will actually be in a better position to answer that.
All right. Okay. Is it clear, Avian Setianeva?
Yes, ma'am. It's clear. Thank you.
Okay, thank you so much for the question. Any other participant who want to ask? Okay, is there any participant who want to ask? Okay, if not, I may want to ask a question, Dr. Burhan. I want to ask in a finance system, what are the potential risks and rewards of using blockchain-based cryptocurrencies as a store of value of medium of exchange in the global financial system?
So the technology is still novice, okay, and the governments all over the world are still actually trying to understand what actually it is, okay. So given this current scenario, many governments all over the world have actually banned cryptocurrencies, okay. So for that matter, like Malaysia is one of the examples, okay. But going ahead, let's say 4 or 5 decades in the down the line, probably digital currencies will be replaced by the concept of cryptocurrencies in future. So it is something we can actually delay it, but eventually we will actually adopt it all.
All right.
As long as the governments worldwide have access to the technology where they can actually control the transactions or at least monitor the transactions, I think that is one of the major impediments that is for global integration of cryptocurrencies.
All right. Okay. Is there any question from the participants here? All right. I think it's very clear that no one here is asking question more. Okay. Maybe it is. Thank you so much, Dr. Burhan, for giving us a very insightful information. Thank you for the audience who come into this course. I'm sorry for there is many mistakes I did, and give a big applause. Oh, sorry. Oh, sorry. I'm sorry, Dr. Burhan. There is one more question from Mr. Adi Setia Pramayuga in the question in the chat box. Thank you for the excellent presentation. We know that research on blockchain has significantly increased over the past 5 years. I would like to ask, if we were to pursue research on blockchain at this point, which direction would be most advisable? And additionally, are there still potential areas for implementing blockchain technology beyond cryptocurrencies and IoT? That's the question.
Yes,
Dr. Burhan.
cryptocurrencies and IoT are the two important research domains as of now when we talk about blockchains. But then, as I said, it is actually even beyond that. Like you can think of some use cases in industries like healthcare, oil and gas. Okay, so you need to figure out a problem in some particular area or a field, and then with the knowledge of the blockchain, you can actually solve that problem in a much better way. So think of blockchain as a solution set rather than a problem. Okay, try to figure out the problem in areas which you can cater by usage of blockchains, like decentralization. So decentralization will solve problems in many fields, like let's say ad hoc networks, let's say military applications, let's say banking, okay, let's say voting systems. Okay, you think of if you have a knowledge in a particular field, you figure out a problem and then try to see blockchain as a solution set.
So there must be any areas we can implement it in with blockchain technology here.
Social sciences, law enforcement. Okay, many systems. Okay.
Okay, thank you so much, Dr. Burhan. Okay, is there any question for Dr. Burhan from participant here? Okay, if there is no question anymore. Okay, thank you so much, Dr. Burhan, very insightful information. And please, the audience, give big applause for Dr. Burhan. Okay, and I'm sorry for many mistakes I did, and I will give the session. Miss.
Okay. Thank you to Dr. Burhan as the speaker and to Ms. Dena Kalia as the one. Well, we have reached the end of today's event. We hope the material presented today will be beneficial for all of us. Let us close this event. Thank you for your attendance and apologies for staying in the question.
Thank you, Dr. Burhan.
Thank you. So I just would like to inform the participants, anybody who's open in collaboration of blockchains. Thank you once again for